and girls. Today we're going to be looking at 8.4 conjectures and arguments. These are big words and they seem like difficult concepts, but once we look at it today, I think it's going to make a little bit more sense. Today we're going to be practicing setting up chairs. All right, so as always though, we start with our mental math. So I want you to write down some factor pairs that would go for each one of these products. So like what times what would equal 12. Okay, and you only have to write one, or you can write more than one. Right, so like 6 times 2, right, equals 12. But 12 times 1 equals 12. So what would be for the others? Now this is actually our lesson today, but I want you to see right here and see if you agree. So it says Miss Soto is setting up chairs for math night. Her room cannot fit more than 35 chairs. She places the same number of chairs in each row. As she sets up the chairs, she makes up a problem for her class with these clues. Okay, so here are the different clues. I'm going to not read them right now, but I want you to kind of look them over and I want you to figure out if one of her students was correct. It says Joy, one of Miss Soto's students, makes a conjecture that Miss Soto set up 13 chairs. So it says that she cannot fit more than 35, but it doesn't mean she used 35. It just means it's not a bigger number than 35. This student thinks the answer is 13. So you have to say, do you agree with her or not? So look at these clues. Does 13 match all of these clues? Does it maybe match 3 of them, but not one of them? Which one does it not match? So I want you to go through and I want you to tell me, yes, I agree with her because, or no, I do not agree with her because that's what we're doing today. We're talking about open response. We're setting up chairs. We're making conjectures, testing them, and then making arguments to justify our claim, right? So if we want to like switch desks around, or maybe if you were having something at home for Easter, right? Or a birthday party, right? You might want to move different possibilities like, maybe I want to have 4 tables here with 5 people at each, or maybe I'll do 3 tables. How many people can I have? How many tables would I need to make, right? You're having to kind of figure that out and see different possibilities that their car could be, but we need to fit a certain amount of rules. Okay, so let's review what finding factors are, and then our new learning today is going to be conjectures versus arguments. So remember, factors we've talked about several times now, that when we talk about factor pairs, okay, that it's the numbers that you multiply together to equal your product. So like 6 times 6 equals 36. 1 times 36 equals 36. So all of these numbers here, okay, are all factors of 36. Now, our new learning today, because we're going to use that information, but our new learning today is making a conjecture. So that's a really difficult word. What is a conjecture? Well, a conjecture is an educated guess or claim based on information that we read in the problem. We can explain our conjecture using a mathematical argument. An argument in math is when we explain our reasons to prove our conjecture. It doesn't mean you're like actually arguing with somebody like, no, I'm right. I know I'm right. Okay, it could look like this. Here's a question. Circle, square, circle, square. Circle the shape that comes next. Would it be a square or a circle? So I have to think, what's my answer? That's going to be my conjecture. What do I think is going to be the shape that comes next? Well, I think the answer should be a circle. Now, my argument is, why do I think that's the right answer? Why did I pick circle? What's my reasons? Okay, well, the reason I think this is because the pattern is a circle then a square, so a circle should come next in the pattern. So my conjecture, my answer, right, is circle. My argument is the reasons why I chose the circle. So it sounds really difficult, but once you think about it, it's not so hard. Okay, so I'm going to go ahead and pause here, and then I'm going to come back and show you how I'm going to use all these different clues from the math message to help me figure out if this student was correct. All right,